Okay guys, so this is Stephen Kennedy, 18242782, and this is the second part of my resource development for my topic portfolio. So what I've done here is, once again, I've done up a model on the GeoGebra software. I find this to be the best software for portraying dynamic mechanisms. I think it's very easy to use, and I know from school it helped myself to understand these mechanisms during my study. So the reason for using GeoGebra as well, it's definitely the hardest thing when it comes to dynamic mechanisms, and especially the Losey and rolling circles. It can be awful difficult for students to portray on a sheet of paper what a mechanism is going to look like just from how they think it works. So it's very hard to understand how the mechanism actually works without a physical model in front of you. So what we're dealing with here is the epicycloid. It's just another subtopic in Losey and rolling circles. And an epicycloid is the path traced out by a point on the circumference. In this case, we're going to go for P. On the circumference of a circle as it rolls along another circumference of a circle without slipping. So what we're going to do here is, what we're really doing with a slider that determines the radius of our circle O, and we have another slider that determines the radius of our circle with a centre at C. So what we do is, here we have an angle TCP. So this angle is increasing all the time, and the two arms moving cause circle C to rotate about O. So as we do this, we can see our point P being tracked the whole way around, and that's an epicycloid. Okay, so we're going to go back and we're going to bring this back down to 1, this down to 4, and now we can see it's kind of like the petals on a flower. So we can already tell here, we can see we're going to have 4 epicycloids the whole way around. So if I just take these out of here, now we can see the epicycloid. So it's the same thing as the cycloid, and I think this is what will help the students understand. It's the same idea with an epicycloid as a cycloid, except instead of going across a straight fixed line, you're rotating the circle around the circumference of a circle. So I hope that using these mechanisms will give students a better understanding before fully diving into a question for a topic like a question on cycloids or epicycloids, and hopefully it will make it easier for them to picture the mechanism in their head. Okay, thank you.